Hello everybody. For this video I'm going to talk about transition elements and which ones you should pay attention to and how to create compounds with transition metals using these Megabuck Legos. So the first thing I'm going to do is highlight the transition metals that you should be aware of. So transition metals that have multiple charges are going to be in where it says common oxidation state on the periodic table. That is what you want to look for. So if there is more than one number in that corner, that is what you want to look for. So take a look at group 1, how group 1 each has a 1, +1. Group 2 each has a +2. Over here, you've got group 13 has all got +3s. And then the anions are all -3, -2, -1 over here in groups 15, 16, and 17. So where it says common oxidation state, that's where you're looking to see if an element is going to have a Roman numeral or not. So let's go through the transition elements and mark the ones that are going to need Roman numerals. So if it's only a single number like this 3, it's a no. If it's got multiple, then you're going to use a highlighter, and you can just go through and highlight the elements that will need a Roman numeral. So that's all I'm doing. Notice how I'm going to skip zinc. So zinc is in the transition metals, but it only makes a +2 charge, so it does not need a Roman numeral. Neither does cadmium or silver. Some of these we will not even really use or see, but it's good to have them highlighted just in case you come across them. I'm not even going to worry about those ones at the bottom because we really don't use those ones that much. So all the ones that I've highlighted there are going to need Roman numerals because of the multiple charges. Then there are some elements underneath the staircase that are considered transition metals. So tin, antimony, thallium, lead, bismuth, polonium. So those are really the only ones that you're going to need to worry about. So if you have a periodic table and you want to highlight the ones that need Roman numerals, you can do that. Or you can just use the periodic table that's online. That's fine. Or the naming cheat sheet that I gave you as well. So these are the only ones that are going to need Roman numerals. Notice how none of the ones in group 1, none of the ones in group 2, and then not some of these up here, aluminum, zinc, silver. So none of those need Roman numerals. So you don't want to put a Roman numeral if they don't need them. So only the various charges ones are going to have the Roman numerals. All right, so how do we create compounds using these transition elements? So I'm going to show you a couple different examples. I'll put my periodic table kind of tucked away there. So the first example I'm going to show you is copper. So copper can make a +2 charge or a +1 charge, okay? So these are the two different types of ions that copper has. Yes, I used a 4 Lego because I ran out of 2s, but these reach 2 charges. So we're only going to look at the front side. So copper 2 and copper 1. So these two copper variations, you have to know which one you're using when you name the compound. So how do you know how to do that? Let's use oxygen as an example. So in copper 2, oxygen's always going to make a -2 charge no matter what because it's in group 16, so its charge stays the same. If you were to put copper 2 with oxygen, there's a +2 and a -2, so those two cancel each other out. So you would write this like I gotta take the cap off the marker. You would write this like Cu, it would be +2 and O -2, so those cancel out. CuO. So that's how you'd write the chemical formula for this compound. But how do we say it? So when you write the name, you have to write out the first element first is going to be the metal, copper. And we used copper 2, so that's important. And the 2 is what's going to be in the Roman numerals. When you write the Roman numeral, you have to put the Roman numeral in parentheses. I like to do it like that, copper 2, and then we name the oxygen exactly like we did before, oxide. So copper 2 oxide is going to be this compound here. If you don't put the Roman numeral in parentheses, it gets confusing, so make sure that you do put the Roman numeral in parentheses. All right, let's try another one with copper 1. So here is the copper 1, and I'm also going to use oxygen again. So copper 1 only has a +1 charge, so it has to get rid of 1 electron. Oxygen needs to accept 2. So see what's going to happen here? I'm going to need another copper. If it's copper 1, I need 2 coppers to balance out the charge on the oxygen. So how do we know this is copper 1? Because if you were looking at the name, you'd be able to find the formula because the charge would be given to you. If you're looking at the formula and you need to find the name, it's a little bit tricky. So how would you write this? This is copper 1, so it goes Cu plus 1. Oxygen is a -2 charge. So in this case, you would have to crisscross these because they're different. So the 1 is going to go down on the oxygen. The 2 is going to go down on the copper. So this is going to look like this. Cu, little 2, O. We don't need to write the 1 there because it's just implied. So what do we call this? And this is where you'd write the Roman numeral. So this compound is going to be called copper, in parentheses, 1 oxide. So copper 1 oxide would be this compound here. You need 2 coppers, but the type of copper that we're using is the copper 1 with the +1 charge. So if you were given just this name and asked to write the chemical formula, you would write these out here like this and crisscross the charges and you'd get this formula. If you were just given this formula and needing to write the name, you would want to look at the charge on the oxygen, because if you uncrisscross these, kind of work backwards, you see that the 1 here, the no 1 came from the 1 on the copper. So that's how you would know. So see the difference between copper 1 oxide and copper 2 oxide. So it just depends on the number of atoms that you need. All right, let's try one with iron. So iron makes either a 2 or a 3. So here's iron 2, and here is iron 3. I know I ran out of 3 peg ones, but there is 3 spots underneath there, so you know that it needs 3. All right, so iron is going to go with, what are we going to use? We're going to use phosphorus as the anion. So do I have a phosphorus? So phosphorus is -3. And it's always going to make a -3 when it forms an ion, because it needs to gain 3 electrons. It's in group 15, so it's 3 away from the noble gases. It needs to gain 3 electrons to be stable. So if we're looking at, I'm going to do the iron 2 first, yeah. If we're looking at iron 2, if it's iron 2, that means that there's 2 electrons that the iron needs to give away. But phosphorus needs to accept 3. So we need to do a little bit of adding compounds here. So I'm going to need another phosphorus. That means I'm going to need another of the iron. And did I make another iron? I thought I made more than one iron, but maybe I didn't. All right, well, we're going to pretend that another iron is right there. So it's going to be Fe3P2. So that's how you would write this one. Fe3P2. And that came from the fact that the Fe was a 2 plus and the phosphorus was a 3 minus. So when you crisscross these charges here, they're going to become the subscripts on the compound. And how would we write that in a word? So it would be iron 2 phosphide. So that is how you'd use iron 2. I can't believe I didn't make 3. I think I ran out of 2s. That's what it was. All right, let's see what happens with iron 3. So remember that the cation always has to go first. So because iron is a +3 and phosphorus is a -3, these two actually cancel out. So we only need one of each. Fe +3, P -3. That means it's just Fe with a P. So we don't actually need any numbers for that chemical formula because it's just a 1-to-1 ratio. So if you come across a compound that doesn't have any numbers, it means that those charges balanced out. But how would you know that this was iron 3 and not iron 2? Well, if it was iron 2, it would be like the one that we just had before, and there would be numbers there. Because there are no numbers, it means that it had to have canceled out. You always know that phosphorus is going to make a -3. Phosphorus doesn't have a varying charge, so it has to be a -3. And the only way to have no subscripts here is if iron was a +3. So that means you're going to have iron 3 phosphide. And that is how we write that compound here. All right, so I think I'm going to try just one more and make sure everybody is understanding how to write the Roman numerals. All right, I'm going to do one with 4. So tin. Tin has a +2 or a +4. I wrote them both on the same one so that you could kind of see that. And I'm going to use a single with chlorine. So chlorine is a -1, and say we're going to use the tin +4. So that means that tin needs 4 chlorines in order to balance out its need to lose 4 electrons. So there's a big, huge molecule there, and it's going to be tin. So tin is Sn +4. Chlorine is a -1. So when you crisscross those charges, you'll get Sn1 invisible and Cl4. So that's what's shown there. And then how do we write this? We would write it like this. Tin, Roman numeral 4, so 1 and then a V, chloride. So that one's going to be tin 4 chloride. So the biggest thing that you need to remember is to crisscross the charges And if you're going from the chemical formula to the name, you'll always know what the charge is from the transition metal if you look at what the subscript for the nonmetal is, because that's where your answer is going to be. So pretending you're uncrisscrossing these, work backwards. All right, so this is a really long video. I hope that helped everybody, and let's do some practice.